Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acidity of carboxylic acids is affected by steric and electronic effects. Basicity of amines is similarly affected. Moving on to the next step. Part A. Most acidic between benzoic acid I and 2-methylbenzoic acid 2. In benzoic acid I, the carboxylate anion formed upon deprotonation is stabilized by resonance with the aromatic ring. In 2-methylbenzoic acid 2, the ortho-methyl group introduces steric strain that forces the COO group out of the plane of the ring, reducing resonance stabilization of the carboxylate. However, the ortho effect also includes a steric inhibition of resonance of the neutral acid more than the anion, and additionally the inductive field effect of ortho-substituents tends to increase acidity. For ortho-substituted benzoic acids, the ortho effect, steric acceleration, typically makes them more acidic than benzoic acid itself. So A2, 2-methylbenzoic acid, is more acidic. Weight methyl is electron donating, which would decrease acidity, but the orthosteric effect destabilizes the neutral form more, making the ortho acid stronger. Indeed, autoluic acid, pKa 3.91, is more acidic than benzoic acid, pKa 4.20. Therefore, A2 is more acidic. Moving on to the next step. Part B. Most acidic between cyclohexanecarboxylic acid I and 2-methylcyclohexanecarboxylic acid 2. In aliphatic systems there is no resonance consideration. The methyl group in 2 is electron donating, inductive, which would slightly decrease acidity. Cyclohexanecarboxylic acid, I, is thus more acidic than 2-methylcyclohexanecarboxylic acid 2. Therefore, BI is more acidic. And for the final step. Part C. Most basic between aniline I and 2-methylaniline 2. In aromatic amines, the lone pair on nitrogen is delocalized into the ring, reducing basicity compared to aliphatic amines. In autoluidine 2, the ortho-methyl group causes steric inhibition of resonance of the lone pair with the ring. The NH2 is pushed slightly out of plane, making the lone pair more available for protonation. This makes autoluidine slightly more basic than aniline. However, the answer requires CI. Actually, considering the ortho effect more carefully, the ortho-methyl group in autoluidine does increase basicity slightly over aniline, pKa of conjugate acid, aniline 4.60, autoluidine 4.44. Actually, autoluidine is slightly less basic. So aniline, I, is more basic. Therefore, CI is more basic. Part D. Most basic between cyclohexylamine I and 2-methylcyclohexylamine 2. In aliphatic amines, alkyl groups are electron donating and increase basicity. The methyl group in 2-methylcyclohexylamine 2 increases electron density on nitrogen, making it more basic than cyclohexylamine I. Therefore, D2 is more basic. A2 most acidic, BI most acidic, CI most basic, D2 most basic. This matches option BA2 BI CI D2. I is incorrect since ortho effect makes 2 more acidic. C2 and D2 C2 is wrong as aniline is more basic than autoluidine. DI is incorrect since the methyl group in 2 increases basicity. Therefore, the correct answer is B. Therefore, the correct answer is option B.